Whoops. I am sorry that I missed class today, or I missed half of it. There's a point on as I'm coming down from my neighborhood in Liberty. I go across this flyover and go into the Shoal Creek area. For those of you that are familiar with the north of the river there. And anyway, as you get onto 435 or near the Shoal Creek area, there's a point there where you can either go this way to 35. And today I wasn't listening to the radio, so if there's any accidents, I went 435 and boom. Usually it takes me probably, once I get to that juncture, 3 minutes to get to Worlds of Fun. It took me 30 minutes to get to Worlds of Fun. So, and I still had a long way to go. I still had to go across the river and through the woods to grandmother's house here to get here. Some of you stuck around. Some of you, I ran into the hallway and you were kind of chagrined you're leaving, going, "Hey, we wait," and I understand that. That's fine. Anyway, while I was sitting there doing the typical male thing, stuck in traffic, not knowing what was going on, I mean, just stuck. I mean, we were just stuck. You start, the way guys handle that situation is we usually start swearing fecklessly to no one and hoping that'll fixes the problem. And then you kind of realize when I heard the ambulances going, I'm going, wait, there's some people with a lot bigger problems than you have. So just sit there, butthead, and relax. Call your work and have them post a sign. So anyway, that's where I was this morning, and I apologize. And so what I was going to do was talk about real quickly what we're going to talk about today. I'm going to save the quiz that I put together for Monday for you to do. So, in the middle of class, like we did the last ones and things like that, like last semester. So anyway, without further ado, let's just go ahead and take a look. I'll probably break this down into like 3 videos because if I make it each one more than 8 or 9 minutes, it takes a long time for it to load, and I'll be here until 6 o'clock waiting for it to take. So I figured smaller bites. All right, so all right, now this is where we left off, and then so what I'm going to do is show you. All we're getting up to now is Coulomb's law, but let's review the bidding real quick on these slides. So let's back up here. So here was your first equation, the amount of charge. Now we know that things don't move about that, the quantum thing is the electrons here, and then it might be over here, but it is a distance away from the nucleus of an atom. And the total charge in a system is equal to Q is equal to the number of protons or number of excess protons or number of excess electrons times the individual charge. And here was your first information that you got was the mass of a proton, 1.67. I always go the 3. Neutrons are a little bit heavier. And then here's the electron, and then here's the charge. And both have the same electric charge. That E is not really for an electron, it's for the electric charge in both. And the proton has a positive charge, the electron has a negative charge. That's what we talked about the other day. Now, and then we ran this little equation here, okay? Talked about changing the like charges repel, and that you can law of conservation during a process, the net electric charge of any process remains constant. So the amount of charge is constant. So if I have a bunch of negative charge here, what's going to happen is the negative charges on this fur are going to run away, and then the amount of electric charge is going to pile up on these negative charges, is going to pile up on this. Or if I'm rubbing this off, if I'm rubbing the electrons off, then I'm going to have a positive. The amount that I rubbed off is going to yield the positive charge on the animal fur. Okay, so like charges attract, charges repel. I don't know what they're trying to say here. Anyway, I think they're showing how an inkjet printer works or something like that. It's in the book. I'd have to read it again. It's been years since I've used this book. So charges flow through things just like heat does. And there are good conductors and bad conductors. The interesting thing is things that are good conductors are heat are also pretty good conductors of electricity. In other words, you know, if you have a copper rod, or especially if you have a silver rod and you stick it in a fire, it's going to get real hot real quick on your hand. Okay. Whereas if you have a block of wood, not so much. All right, we talked about charging. There's charging by contact, charging by induction. That induction is how you get a positive charge, and contact is how you get a negative charge because the electrons flow. And then they did a good job of showing. So if I get this ebonite rod close and don't touch it, then these guys run away to the other side. They go, oh, okay, I'm over here. And then if I attach a grounding wire, while I keep that over here, they run down to the earth, and then I remove the grounding wire, and then the electrons move back around, but they just distribute themselves around so that the protons look like this. So remember, it's electrons that move. Here's what I was explaining about the wall the other day in class. Here are the forces. What's the equation for the force? Here it is. It's called Coulomb's law. All right? All right. And what we have here is 1/4 pi. The echo nut is the electric. This is the permittivity of free space, is what we call it. Okay. And it's a constant, just like the gravitational force. Doesn't this look like the gravitational force, where F was equal to the big G times mass 1, mass 2, times the distance between the centers of the two masses? Same thing here, except these charges are so small that we just, from one charge to the other, you know, their centers are so, they have a lot smaller radius than that of the Earth or the Sun or things like that, okay? So, and it is equal to 8.99. All right, they're going with 8.99. Last year's book, the book I've used for the past 5 or 6 years, or actually 8 years, had 9.0. Let's go with 8.99 so that on our homework it'll work out good. I think that'll, because when you start dealing with numbers like this, and then putting in charges that are 10 to the negative 7 and stuff like that, and radiuses that are 10 to the negative 5, it could really, you know, that could throw off the sig figs enough so that you'll be doing the work right, but Wiley Plus will tell you it's wrong. Like charges attract, force in, force, or like charges repel, opposite charges attract. Okay, and we did one of the homework problems. I think it's problem number 8, which or 24, which we will examine. But here's the Bohr model of an atom. Now, the electron is in an orbit. Now, we know that's not exactly true, but at the same time, we can use this to approximate the force. And Bohr used this to actually calculate the radius of an orbital radius of here's the proton, positive E, here's the electron, negative E, and we could find the velocity, because do you remember? You had the force, the electric force that's holding it here is equal to mv squared, and we could solve for v if we wanted to, and that's what they're doing here. They're solving for, so we're going to take certain forces that we used in physics 1 and transfer them over to physics 2. Okay, use the same ideas, you know, just because before, when we were looking at centripetal force, we were looking at airplanes flying in a circle or merry-go-round or something like that. Hey, still, that force is caused, that net force that's caused by that centripetal acceleration is equal to this, and we could calculate the speed of that electron going around there. And look at this, 2.18 times 10 to the 6 meters per second. Now we could also calculate, since we know the force, we could calculate what the acceleration is of that electron. If we divide that by the mass, the acceleration is ginormous, ginormous. If it would go straight with that acceleration, it would exceed the speed of light in no time. Like within a split, like within a picosecond. This is still below the speed of light. Okay? And we can do forces, we can add them together. All right, this is where I'm going to stop, because we can add forces together. It's an algebraic thing, and we'll start here on Monday. I'm going to show you the 2 homework problems we did today, okay? And then everyone will be kind of caught up, all right? Now, does this mean I'm postponing the test? Heck no. not postponing the test, but I'm just going to give you a test over what we've covered, though. I'm not going to say, oh yeah, by the way, there's 4 sections that we missed on that because I got caught in traffic on that Friday. I need you to study on your own. I'm going to test you over it. That's no. Homie, don't play that. So you'll be fine. All right, I'm going to go on to the next thing.